AngularJS, how does a web browser work, and how AngularJS extends the web browser. First, what is AngularJS? AngularJS is an application development framework for single-page web applications. A single-page web application, as you know, is one in which a single page of HTML with JavaScript is downloaded from an HTTP server. And it looks like it has multiple pages that transition one to the other, but really it's just a substitution of a template into the DOM. So the first page is one template, next page is another template, and so forth. AngularJS is written in JavaScript, and you can think of it as an extension to the web browser. It adds facilities to the native browser that make it into a super browser. One of the issues when you're starting out with AngularJS is how do you practice and how do you learn the facilities that are built into it. One of the nice ways of doing it is with the Plunker website. That's plnkr.co. And you'll see here you can write a very simple application or a more complicated one and run it right away. You can install or use the libraries that for this particular application, get them from a CDN, so you don't have to install anything. And you can very easily test things with that. Another way of learning to use AngularJS is build your own little sandbox. Something like this, where you have code also from a CDN, and you put the JavaScript you want, controllers, directives, whatever, and then you concatenate them with the CDN code, and you can just run it with HTML over here. This is nice because you can keep everything together. Unfortunately, you have to install an HTTP server to run this, maybe something like HTTP server from NPM. But if you want to grasp everything in one page, this is the way to go. You can also take a working application and change it, experiment, set breakpoints, modify things, and use the browser developer tools, the console and the debugger, and also add-ons to console and debugger like Batarang. And learn an application that way by taking one apart and putting it back together again. We said before that AngularJS can be thought of as an extension to a web browser. So let's look at web browsers and how they work. What do web browsers do? Basically two things. They process events and they parse HTML from HTTP responses, building a document object model and rendering the page. Browsers are event processing machines. Browsers have a single thread of execution and they wait. An event happens, they respond to it by driving the callbacks for that event. They wait, another event happens, they respond to the callbacks for that event. In that way they're implementing the observer design pattern, where you have an event and you have callbacks that register for the event. The event doesn't know how many callbacks it has or what they are. It just knows that it takes everything in the list and fires the callbacks one after the other. That's the design pattern of observer. Events can be initiated by a hardware event, that is a click of a mouse or the movement of a mouse or the response of a in-network interface when it's notified that it has something coming in on the network. But these are hardware events. The browser then takes them and turns them into browser events. Here's the difference. So let's go back to our Plunker code for a minute. When you move the mouse, it goes from one coordinate to another. So from, say, x, y to x1, y1. However, when you move it into, say, an input box, it's moved to another set of coordinates, and the browser knows that it's now over an input box, and it fires a browser event. The hardware event was the movement of the mouse, and now that it's over a browser element, the browser then will fire, say, in this case, a focus event. When you move out of the input box, it fires a blur event for that element. This is the way that the browser turns hardware events into browser events. And there are some browser events that are not initiated by the hardware. So you get HTML over the network interface and it's rendered into the DOM and loaded in the page. The browser issues the DOM content loaded event. That's not driven by the hardware. That's driven by the browser's processing of the HTML. The reason it issues an event is so you can register for a callback. There's a very nice program written by Philip Roberts called Loop that illustrates how the browser works. This is the Loop program. The link to it is in the show notes. In this case, this is schematically what a browser is. The call stack is what actually executes at the moment. The web APIs in this case is the event queue. And then the callback queue are callbacks from the event when they're fired, which then end up on the call stack to be executed. So let's run this little program here and see how the browser processes events. First of all, when you start running the program, you'll notice it pulls the on-click expression and it executes it. That creates a callback. It creates a web event. Okay, when the event is fired, the callback for the event, in this case the set timeout, is put on the callback queue and executed. The set timeout actually causes another browser event which is put on the event queue, and when the timer pops, which is another event in the hardware, it's put on the callback queue and executed. So let's watch the whole thing. When you do the click, you see the click is put on the callback queue, and it's puts another event on the event queue, which then fires and is put in the callback stack. You can play around with this. This is a really nice little program. The other thing that browsers do is that they parse and render HTML. When an HTTP response that contains HTML comes back on the network interface and drives a browser event, the browser takes the HTML and it parses it, and it constructs a document object model, or DOM, that's a tree representing the elements in the HTML page. It then also parses the CSS and combines it with the DOM into another type of model that is rendered by the rendering agent in the browser. The rendering agent actually runs in a separate thread. I lied when they said it was only one thread. And it runs quite frequently. So if you change the DOM and change the elements in the page, or insert elements or remove them, the rendering agent will pick that up and it will render the modified page. How AngularJs extends the browser. We talked before about how you can think of AngularJs as a browser extension. And remember, browsers do two things for a living. They process events and they parse and render HTML. Well, these are the 2 points where Angular gets control and enhances the browser. It extends the browser's event loop, and it extends the browser parser. In this diagram, this native section is the browser. Events are put, as we saw, on the event queue. When the events fire, they drive JavaScript callbacks. Ordinarily, the JavaScript callback will just go modify the DOM, and the browser will render the modified DOM. In this case, all the callbacks that are put on the event queue that are relevant to Angular have the $apply function in them. So in that case, when the event fires, it goes into the JavaScript context and JavaScript starts processing it. JavaScript runs the $apply function and goes into the AngularJS context, this yellow box here, which is the digest loop. This modifies the DOM, and again, it's rendered by the native browser. I mentioned that when you're in an Angular program, the events on the event queue do not make native callbacks as they ordinarily do. They make callbacks that have $apply in them. Well, how does that happen? One of the ways is that inside of an Angular program, what look like normal page elements are really Angular's version of a normal page element, and they issue a $apply when a change happens. Let's take a look at that. Here's our plunker again. You'll notice that this is an Angular program because it's in the ng-app directive. And here we have an input box. Now this looks like a regular HTML5 input box, but it isn't. It's Angular's version of the input box, an Angular directive. So when it's compiled, it ends up making JavaScript that calls the $apply as opposed to native callbacks. You can see this if you look in the Angular documentation. It has documentation for an input box. Looks like an input box, but it does Angular-ish things. and the most important, issuing the $apply so that it'll go into the Angular context. Some page elements do not have Angular substitutes, such as div. If you want a callback that's an Angular callback on a div, you'll add a directive like ngClick. ngClick, when that event is fired off the browser's stack, will drive $apply just as if it were a callback from input or checkbox or whatever. When the digest loop runs, it always runs against a scope. And if we'll look back at our plunker, we'll see that inside of this Angular application, because it's ng-app, we know it's an Angular application, we have an ng-controller directive. And our input box is inside the controller directive. Well, that controller directive defines a scope. There are a few directives, we can list them later, that do define scopes. And when the digest loop runs, it will run against the scope for this directive, for this ng-controller directive. Now let's talk a little bit about the digest loop. This is what runs after the $apply function brings us into the Angular context. The digest loop has basically two subloops in it. One is the watch list, and the other is the eval async queue. The watch list is Angular's implementation of an observer pattern also. What you're observing is elements in the scope. When they change, and Angular checks them to see which ones have changed by what's called dirty checking, it runs the callbacks that are associated with those watches that are put on scope elements. You can issue your own $watch function and create a watch inside of a scope or somewhere else. Angular does this for you in many instances. For example, if we go back to our plunker, these two mustaches, the interpolations, this is actually a watch on the scope element name. So when the name changes, dirty checking inside the digest loop will notice it and run the callback, and in this case it's interpolating it into the HTML and also running a filter against it. That upright bar, uppercase is a filter. That's actually outside of the scope of this lecture, but it's easily, it's pretty intuitive. All right, the other thing that happens inside the digest loop is the eval async loop. These are functions that you can drive yourself with the eval async call in a scope somewhere, and whatever you've called with eval async is guaranteed to run on the next digest cycle. It's a good substitute for set timeout, which is not an Angular construct. That's a browser construct. Sometimes you'll write a set timeout just to make sure that a function will be called after the event list is processed and a callback from an event. This will serve the somewhat similar function. We just mentioned that Angular context, the digest loop, always runs against a particular scope. And what happens with digest is it might modify the DOM, and there might be a watch on a DOM element which drives an Angular callback, and it will again make it dirty, so the digest loop will run again, and it'll run and run and run until the DOM is stable. A couple of notes on Angular's scopes. The native browser has one global scope. Now, of course, you can make subsidiary scopes by writing a function and declaring something with a var inside the function that'll have a functional scope. And in ECMA 6, you can have closure scopes. But the browser itself really has one scope. If you don't put a var on a variable, it will be part of one global scope. In Angular, there are multiple scopes that are created by different directives, ng-controller, ng-repeat, ng-include. You can find the list in the documentation. As we mentioned, digest always runs against the current scope, as we saw in the HTML inside of an ng-controller. And this is actually an important point for the MVC pattern we'll see in the router. When you set a new controller, you're changing the scope. And you can think of a controller as actually a scope. It contains methods and it contains variables that are active within that scope. If you change the controller, you have different scope and you have different methods and different variables that are accessible from directives. We said that there are two ways that Angular extends the browser. One is the event loop, which we just looked at, and the other way is extends the parser. Now, the parser does not, in the browser, does not parse tags it doesn't know. So if you have Angular tags, but you don't have an Angular context or an Angular program, those tags will just be ignored. If you are inside of an Angular program, Angular parses Angular directives. It separates them out. Anything with ng is an Angular directive that comes with Angular, or you can write your own directives to do whatever is appropriate for your application. In fact, you can build up a DSL out of directives. The Angular parser also sets watches when it we already looked at that, when it parses the input box, the checkbox box, the checkbox, the Angular substitutes for HTML5 elements. And it also sets up watches with the interpolations, the mustaches. This schematic shows how the Angular parser gets control when a page is loaded in the browser. The browser loads the HTML when the HTTP response comes in and builds the DOM out of it. When the browser finishes building the DOM, it issues a DOM content loaded event. Angular, if there's an ng-app directive on the page, has registered itself as a callback on the DOM content loaded event. It then the compiler then runs, it looks for Angular directives in the page, and it builds HTML based on the directives and merges it into the DOM. It also builds link functions, which we'll talk about in just a moment. We just showed how the Angular compiler gets control after a DOM content loaded event because it registers itself as a callback. The compiler can also run whenever the $compile function is executed. This can be in any code that you specify to compile a piece of HTML that contains Angular directives that can then be inserted into the DOM, or when the router, which activates one logical page after the other, sees a new logical page for the first time, it will issue $compile to compile the directives in the HTML. As we say, Angular compile locates the directives in the HTML that is given to compile, and it generates HTML which is inserted into the page. Now, at the time of compile, which only executes once, you don't know what the scope, or Angular doesn't know what the scope will be that is actually executing any functions inside of the directive. So to execute those functions, you have to have a scope. What Angular does is it generates a link function which, when a scope is activated, will run against that scope. AngularJs is a framework for developing single-page web applications. AngularJs works by extending the native web browser by intercepting the browser's event processing loop and enhancing the browser's HTML parsing. There are many topics that we really didn't cover about Angular that you should read up on if you're going to be writing Angular code. One is the injector, very important, but we just didn't have time to cover it. Angular services, Angular testing, including Jasmine Protractor. Angular events, these are distinct from browser events. Angular has its own broadcast emit and registering callbacks on its own event system. And Angular resources, HTTP and promises. This is how Angular communicates with web services. And also filters. We touched on that a little bit in the Plunker example. But these are things that the next thing to study about Angular. Here's a list of resources available for